Hello? Hello, one sec. Whoa. Whoa. Hello, one sec. Oh my God. What's happening? Hold up. Oh my God. What? Hello. That is not good. One second. One second. You're there, right? Okay. Pardon me. Sorry. Okay. Are we back? Okay. Hello. Hello, folks. Oh, it's our second day and no one's doing video. Am I shaming anybody? I can do a public shame, right? So we're in our second day and no one's doing video. Let me back up. First of all, can you hear me? Can I get any acknowledgement that you can hear me?
Yes, sir, I can hear
Oh,
you.
thank you, Vincent, for using your voice. And thank you, Vicky. And thank you, Gabriel. Okay, so we're here. So that's good. Sorry about that. That was definitely an uncomfortable start. Oh, also, hold on. Sorry, we're still here. Hold on. This is, why is this not? Hold on. Wait, are we screen sharing? We are not screen sharing. That is the problem. Hold on. Hold on. None of this counts. This is not class. I mean, it does, but why are we not screen sharing? Hold on. Share. Okay. Sorry. Okay, let's do a redo on this. First of all, hello. But second of all, what you want to do, it's good. See, thank you. Thank you, Ms. Lee. Thank you. I appreciate it. Not to so again, so it's good to see you guys again. What would be a good habit is if you want to just like put a hello in the chat, especially once you can hear me, to acknowledge that you can hear me or blah, blah. I don't just mean Ms. Lee, I mean anybody, everybody. Also for the whole game participation thing, for those of you who are quieter and stuff, every time you want to submit for 5 points, like every single night, including tonight, even just writing, I wrote hello in the chat, like counts. So it's good. Thank you. So I like the hellos. It makes me feel, so thank you. So great. Thank you, Ms. Lee. Thank you, Melanie, and hello, Melanie. And I'm going to do this. And this is also, maybe it's a secret way of taking attendance. You can think of it any way you want, but I say hello back. This is a way for us to get started and make it a real class. So yes. So thank you, Ms. Lee. Hello. And I'm saying Ms. Lee because, okay, no, I shouldn't do that. Do I say Zhang or Zhang?
You can call me Annie. I just renamed myself like
Right. Annie. Okay.
So
All
hopefully
right.
that'll be easier.
Okay, yes. Okay, thank you, Annie. Okay, so thank you and thank you for the video. And hello, Melanie. Thank you for the hello. And of course, by the way, each day is going to be a higher ratio of physics material to human stuff. Believe me, we're here to do physics. I know that, but I feel like we do it in a framework of humanity. So anyway, hello. So this part will go faster and faster each day. Hello, Amelia. Also, I'm still learning your names, etc. So correct me. Hello, Amelia. Good morning, Vanita. Hello, Jocelyn, and thank you for the I can hear. Awesome. Hello, Vicky. Hello, Jean. I think it's Jean. Correct me if I'm wrong. Hello, Gabriel. That one I know. Okay, so hello, all of you. Good to see you. Thank you. Is that every? Okay. Oh, okay. We're going to start getting into the material now, and as you see, you've already started to get some feed. We're going to talk about the feedback you just got back. Well, we'll talk about everything. Specifically, we're going to talk about the 5-step method, and we're going to talk about points. So a couple of logistics to be clear first. And again, remember, at any time you can stop me or put in the chat. If you're even uncomfortable, whether you with any question you have, or if I'm on the wrong topic, or there's burning desires, when in doubt, put it in the private chat. So at worst, if I say I can't deal with it, I can't, but I won't embarrass, I won't try to embarrass you. So here's where my head is. In terms of physics that we're starting to get to, like the NumberLine homework number 1, of actual real physics homework was called NumberLine. Technically, it was due right now, when this class started 5 minutes ago. So if it came in right then it's totally on time and it's totally great. But of course, if it came in right then, of course, I haven't graded it yet or anything like that, and that's all fine. We're going to start talking about it today. If you happen to have turned it in, even like an hour ago, hopefully you have seen that you've already gotten feedback and points on it. Hello, Gabe, thank you for the video. Awesome. So hopefully, if you've already turned it in, you will see that you've already gotten feedback and points. Now, that's not always going to go that way. I'm going to fall behind just like you guys, and I'm going to get worse. And my feet, yeah, I'm going to fall behind. And more and more, it's going to be up to you to interpret my feedback, or my feedback is going to be shorter and you're going to have to know what it means. And that's what we're going to talk about today. But the first thing I want to make clear is if you already turned in the homework and you already got it back, you already got a ton of points on it. It's totally already understood that you're very on time and you're very thorough and you're already getting a ton of points for just that fact alone. If I gave you any feedback at all, if I gave you anything less than a perfect score, I want to make this clear. This is not just the first homework. Then you're going to resubmit that and get all the rest of the points. Like nothing, no one's being punished or anything like that, especially if in some cases the work was really good, but you don't know yet exactly what I want the work to look like, which is what I'm going to explain today. So I gave you the advice of how to make the work look exactly like what I'm looking for. And as soon as you resubmit and do that, you'll get all the remaining points. So right now we're in the stage of the course. I just want to make it as clear as I just want it to be as clear as possible what I'm looking for the work for the next 2 semesters. And again, any feedback I'm giving you right now or anything I'm saying, if you want all the points, this is what you do. It applies to the exams as well. All of this is like sort of practice for the exams. Okay, so long way of saying anybody who's done the work at all, like if they submitted anything on time today, you're still all like have a perfect, A, like you're still all in a chance for having all the points. Ideally, so okay, that's number one. And when you want to and this is always true for all the homeworks until I say otherwise. It's always true that you could just keep resubmitting for the rest of the points. Also, because we're all going to fall behind, it's always people fall behind in different ways. Well, not some of you will not fall behind. I will. So I'm also going to say, like, for next class, yes, the first priority you would want to do is just try to fix whatever your first homework was to get the rest of the points. And you'll be able to do that even if you still don't know all the right answers. It's not about all the right answers. It's about the process. But second of all, then you'll want to move on to the second homework, which will be maybe a little bit harder. The same thing is going to apply there, but I want to warn you in advance. We're going to get quickly into a system where the minute you hand in the homework, as long as your homework's on time, you will immediately get it back with a huge amount of points just for doing that. And you may not, if you ever get, what I'm trying to say is, if you are missing points, you're either waiting for feedback or you know what you're supposed to do. Or if ever I give you the majority of points right away, but they're still not all the points, and then the homework is just sitting, why can I not say this? I'm trying to say that sometimes if the homework sits for a bit and I've given you the majority of points, but I didn't look at it carefully yet or something, you can always write me a note later or re-upload in the thing and say, I'm still waiting for feedback. I'm not sure what I did wrong, so I can't upload yet or something like that. And at a certain point, if I can't give you the feedback in time to ask you to fix things, then I'm just going to give you the rest of the points. It's on me, in other words. So one way or another, I'm not explaining that well, but when it comes up, I'll tell you again. But it's just a long way of saying, don't ever be concerned with when your first draft doesn't have all the points. It's always a first draft. That's what I'm trying to say. Okay. Now, oh wait, so no problem. Okay, I'm looking into private chat. Hold on one second. Okay, hold on one sec. Okay. Obviously, I want to start talking about the homework and how to do it and the physics and all of that. You do notice, so please notice again, it's always going to be like this. You're trying homework before I explain the concepts. Like it's like a reverse classroom or whatever. That's the way it is in physics. It's always the way it is. Um, it doesn't mean you're doing something wrong if you're like, wait, when did he even talk about this? You're not doing something wrong, and I'm not doing something wrong. You're trying to figure things out first, and then we're going over them like recitation or whatever. So, because we're trying to learn how to think about things that we haven't thought about before. That's what physics really is. So never be surprised. Like the next homework is about it'll give you concepts in the sheet, but don't think you were supposed to have read in a textbook or you were supposed to have played a video. You're not. You can go online and look at Khan Academy. You could do whatever you want. And I should make it, you can and please should help one another. Everything is totally open source, open world. All of this. That's kind of why I don't use a textbook anymore, because it's like stupid. I mean, you find the resources that you like better. It's just whatever. So you're allowed to look at anything to do the homework, but I'm not expecting that you had to have to try the homework. Okay. Again, stop me if any of this is not making sense. We're going to start doing physics in a minute. But last thing also, in terms of game and participation, I hope it's becoming more and more clear. I hope you saw like tonight already game 2 has been posted. It's the same thing. Sorry, not game 2. I mean, turn 2 of the game, because today's class 2. So that's already been uploaded. So that's due at midnight tonight. And that'll be true every single class. If I ever forget, if you don't see it right away at the beginning of class, please remind me. Like on the 3rd class, just say we need turn 3. Where's turn 3? And I'll just do it. And so that's for every single class. Just a quick note on your part where you say, I said hello or whatever. And then you get that back. Hopefully you've all seen that it's that easy and it's that quick. But if you did, like, again, not to call him, say, for example, say you're Jocelyn, who's showing Avatar right now, right? I mean, she's showing like a cool, which is actually, I'm leading it. Very nice. Actually, it's very spiritually uplifting. So she's not just showing a black box. She's showing an avatar. So tonight for game turn number 2, absolutely for turn 2, she can write. Today, my way of participating is I showed an avatar in my box. Like she can write that. That counts. And that's 5 points. But also, she should double dip. Like she should also go to the effort of finding that avatar portal, and she could put like literally the same document in there and just say, here, I showed avatar today. Here's my screenshot. So you get the points for both. Like you should double dip or triple dip or quadruple. I hope that's clear. Stop me if that's not clear, but I'm saying, and if you're a person, like she already did that day 1, or like Gabriel showed video day 1, and he did. He submitted in the video portal like I showed video, and he got the points, right? Today, since he's showing video again, I'm not trying to embarrass, but I'm thanking him. If he's going to show video again, I mean, since he's showing video again today, he would go to that same video portal tonight or to whenever he'd go tonight, and then because he's now going to upload again, and I want him to keep everybody has to listen to this because this also applies to uploading revisions of your original work. Okay, it's the same thing. So either in the case where you're uploading another screenshot of another day that you showed video because you want the more points for that, right? That's example 1. Or example 2, you've done homework 1 NumberLine. You got 17 out of 20 points, which is very good. But now you want all the 20 points. So you looked at my feedback, and now you're going to make a new draft and submit it. I mean, upload it. So in both those cases, you want your old draft to stay there. That's actually really important to me. You want the old draft to stay. So in Google Classroom, what you have to do, correct me if I'm wrong, I'm pretty sure, you go to the assignment portal, or to your side of it, you actually hit the button that says unsubmit or unturn it in, or I think it's called unsubmit, or be correct. If anybody knows what I'm talking about, please put it in the chat.
It's called unsubmit.
Thank you very much. Awesome. By the way, that counted as voice. She just got points for voice. Also, that's multiplayer co-op because she totally just helped someone. The someone was me, but that's fine. There's like a million other things. So thank you. Okay. Anyway, thank you. So you hit unsubmit. That means, it doesn't mean your old document is coming down. It means now like it's notifying the professor that like no longer what you have up there counts as your thing. So now you attach the new file. You keep the old file up there, you attach the new file, then you hit submit or turn it in again. And you always want to do this. For those of you, like, I don't know, maybe Annie, say she's going to show video every day. So she's going to get like a stupid amount of points. Like seriously, like not stupid, like a lot. It's not an exaggeration. There was one student in this class like 2 semesters ago who basically secured her A just by showing video every single day. Like I'm not, but anyway, so say Annie's going to have, she wants there to be a million docs up there and each one will have the date and everything. So I can literally see, like at any given moment, I literally know, okay, multiply 7 points by each one of these files. So we're both clear on exactly what's happening. So and more important with the physics, absolutely every time you upload a new revision, a new draft, you want to keep the old one. You want me to see that that's how hard you're working and etc. Okay, anyway, and there's other reasons for it too. But anyway, I hope that's clear. So that's what you're going to do for all this. I would like to get to physics. Are we, can I just get thumbs up or electronic hands? Are we clear like so far? Is everything? Yeah. Okay. Yeah. Okay. Thank you. Thank you. And thank you, Miriam. Thank you, Vanita. Thank you, Jean. Thank you, Justin. All right. And thank you, Gabrielle and Andy. Okay. So now I want to get to actual physics. What I'm going to do now is start going over the NumberLine homework. By the way, maybe some of you didn't even do it at all yet. So that means, okay, so it's late. So maybe you're not going to get like full 100% credit, but still, you're going to get tons of credit. Don't not do it now just because you didn't do it before. And now I won't finish it today, maybe, but of course, I'm going to start giving you answers and solutions. That is okay. It is not cheating to incorporate what I do into your revision. Like, that's the point. That's why it's class. So it's not, it is like cheating to like wait for that to start, but you get my point. So I'm going to start going over this. Is now fair game for everybody. But those of you who, okay, so sorry, hold on. Okay. As you know, what I'm doing right now, I'm going to start going through NumberLine. But I'm going to do it according to what many of you noticed, maybe I mentioned, according to a document that's in the tools section of Google Classroom. I'm going to show you what I mean by presenting a problem according to the 5-step method. Okay, so what I'm doing, I'm going to drag this out now. Forgive me, those of you who already rocked the homework, which is many of you. Well, I think every single person in this class can benefit somewhat from what I'm about to do. But it's clear that some of you pretty much already get it, which is great. What I'm about to do, I'm going to drag it out a little bit. Again, every day in the class, we're going to go faster and faster. And but right now, I'm going to drag out and show you as best I can exactly what I would expect you to do on your side when you're when you're presenting any kind of solution to any kind of homework problem or exam problem. Okay, so for starters, notice I'm on my own blank sheets of paper now, right? Like this is like I'm pretending this is a blue book. This is not the question sheet. This is my own blank answer sheet, right? So, of course, it's labeled at the top, NumberLine. Of course, it says it should, okay, and I'll like whatever. It says my name over here. Okay. So now, according to the 5-step method. Oh wait, I'm looking in the chat. Okay. And again, this is a abbreviated version of this is in tools. Maybe you should be consulting while I'm talking, but this is my expanded explanation of it. According to the 5-step method, the first thing you're going to do on your blank sheet of paper for any problem that's being assigned is you're going to provide your own, you're going to provide your own diagram and fact pattern. So step 1 of the 5-step method is DFP, diagram and fact pattern. So here's where you are in a visual way presenting what the situation is, what the scenario is, like what are we dealing with, right? And this also would apply to experiments and stuff like that. But specifically the diagram that you're going to present now be careful with this. The diagram, by diagram, I really mean picture, i.e., I actually don't mean a graph. I generally speaking don't mean a graph or a hold on, I'm just going to switch the view on this. I don't mean a graph or a free body diagram, if you remember those from high school physics, or I don't, at this stage, I don't mean a technical solving tool type of diagram. I mean an informal picture of the facts of the situation. So you're not solving anything yet. You're not representing anything in a sophisticated graph way or something. You're just presenting what the situation is in a visual way. And the goal of this picture is not only to make this physics, space and time, as opposed to just math, but it's also specifically, it's where you're going to define all the terms of the problem through the labels in your diagram. Like that's what you're going to do here. Now, often the actual problem itself already gave you a diagram like I did right? So often maybe you're copying the picture that I gave you, sort of, that's fine. But often I won't give you a picture. I've found, and that's when this is even more important. I have found on exams in particular, people often get confused. If I didn't give them a picture, then they think they're not supposed to give a picture. But if I didn't give you a picture, it's even more important that you give a picture. So you need the picture, step one, always. In the case where I gave you one like now, you can basically copy mine, but by hand. It's okay if you use mine for guidance, but you cannot copy and paste it on a computer because the point here is the exercise of going through it. My diagram looked something like this. So the diagram was something like this, right? It was like a number line at the front of the room. It was labeled 1, 2, 3, as you know, and many of you did this. And I think in the case of this problem, the numbers were labeled in feet. So that's what they are. So we don't have to convert that. If that's what they are, that's what they are. And I think the instructor, you'll correct me, started like here. And he's initially going like that. Stop me if any of my facts are wrong. And then this is obviously a warm-up exercise type of problem. The problems get more sophisticated than this course. But then I have to put the facts down. Well, here, no, okay, I'll just do it like this. He goes, stop me if I'm wrong. I believe he goes like this. Then he goes like that. And then he goes like that. Tell me if I'm wrong. It's been a while since, but I believe that's right. And this first thing, oh, right. Okay. Right. So something like this, you do it your way. But this is the situation visualized, and it's all the facts that were given, including this crucial fact, each interval and constant speed. So, okay, so you notice that my diagram, it's similar to the one that's given, but it's not the same. That's the point. It's like my own version of it. One note you may want to, if you're taking notes, please be taking notes. Of course, this is sort of a primitive problem, but in the key thing here, I'll even try to help. The key thing that you want in this picture, the key thing, even if you're copying mine, when I say diagram and fact pattern, what you'll ultimately see as these problems get more sophisticated is that what's really happening in this picture is that the labels in the picture should be letters. The letters that we're going to use as constants and variables in the math that we use to solve the problem. So like once we start labeling things with X for distance or T for time and things like that in the diagram, like here, like in this case, like you might say something like this is X1, this is X2, this is X3, or something like that. Again, here it doesn't really lend itself because it's kind of a primitive problem. But generally speaking, you'll know your diagram is complete and correct and useful if every single letter that you ever use in your equations or in your math is a label in the picture. That's the test. That's the point, is that you're defining the constants and variables for the math that you're going to use. And then when I say fact pattern, then underneath what will generally happen is you'll have something like in the picture, like X and T and whatever, showing what we mean by that in the picture. And then underneath, it'll say like, in this case, X equals 3 feet or T equals 4 seconds or whatever. So ultimately, what I mean by labels is the constants and variables, the letters. What I mean by facts is the numerical values of those. Okay, so that's generally what's going to happen. So you present this first, just like I have, on your own blank piece of paper. That's step one, diagram and fact pattern. Then step two, and step two, so much more important than people realize. I didn't realize how important this was until I was in graduate school for the second time, like seriously. Step two is WIQ. What is the question? So so after you've presented a diagram, you're literally going to present the question to me in your distilled, like simplified words. They might even be symbols. Here's where you're gonna get just that. You're gonna get the question across in the simplest but clearest way that you possibly can. So in this case, we're talking about question one. And I believe question one is like what distance is covered by the instructor in the entire 8-second journey? So you don't use my words. I mean, of course, some of the words will overlap, but you don't use my words and you don't copy and paste my question. And far more, you don't be doing this on my question sheet itself. So you distill it down and say something like, from t equals 0 to t equals 8, distance equals something like that. Now, and ultimately, again, right now we're still at the beginning of the course, so we don't have like equations and stuff yet. Ultimately, distance wouldn't be a word. It would be something like x equals. And you can write it that simply, but you got to make clear, and you probably should, but you got to make clear what the question is in your words. So part of this purpose is to show that you understand what the question is. That's why you can't just copy and paste it. But honestly, sorry, question.
So
Sorry.
we're not rewriting the question in our own words for us to understand.
No,
Is
you
that
are.
that?
Wait, sorry. Wait, great question. And thank you. And you just got tons of points for that. So hold on. I do want you to rewrite it your way. And yes, it's partly to show that you understand. There's another reason as well, but yeah, like, like on the, and wait, I'm going to totally stay with you here for a second. Like, oh, I keep switching the thing, but it doesn't screen share. I'm sorry. Like, right. Like on my sheet, look, you notice already, I use way more words than is good in general. So my thing says, what distance is covered by the instructor in the entire 8-second journey? I mean, I feel I have to use all those words to make the whole thing super clear to like all of you. But once you get what I'm asking, yeah, you don't want to use all those words. You want to simplify it down. And it can be like letters and symbols as long as it's a clear, complete thought. So yeah, yes, and part of it is you're showing me right off the bat that you get what the question is. So wait, that was Melanie, right? So am I confusing you more, or did I actually answer what you asked?
The way how you wrote from t equals 0 to t equal 8, and okay, I see what you're saying. You
Oh.
kind of, I'm not sure if you wanted it in like short form, or if you literally wanted me to just rephrase the question in a way I understand so I can go about the problem.
Oh, wait, great. I see what you're getting at. I think I see what you're getting at. Great point. Okay, yeah. My answer is yes, what you just said. Like, I want you to do the thing that you're saying. I think what I just confused, I'm really glad you're asking. I think why I just confused you slightly, and I probably confused a lot of people, is right. These words that I just put here might have made it even more complicated for some of you. I see that. When I wrote from t equals 0 to t equals 8, that may not be the way you think at all. So that's probably what's just confused you. I'm just kind of going out of my way to make it look different from the way I had it in the sheet. So I'm saying from t, so this is right. This might not have made it more simple for you. You make it simpler for you. You write it a way that works for you. And also, the reason I just wrote it this way is I'm trying to encourage, it's totally okay if your simple way uses like less English and more like letters and symbols and stuff, as long as they really make sense to you. That's totally fine. Okay, great. Thank you, Mel. Oh, and so Melanie just got tons of points. She used her voice. She actually asked a question. By the way, this even counts as that portal where it says, please go back. There's a portal that says like, please, which basically means like, whoa, before you go any further, wait, what's going on here? She could submit points for that. And then she wrote in the chat, okay, got it. Meaning like, polite way of saying, yeah, ma'am, you can move on now. So she could submit to all those portals this very same moment that she just did, can go into all those portals. And I'm saying again, I'm not going to spend every class over talking about this, but I want you guys to see where I'm coming from. Like, that's how this works. And I'm really glad she asked, because yes, okay, I'm ultimately saying write the question in your own words. And here's an example of different words from the sheet. But if this didn't make it simpler for you, then do it your way, not my way. Right. Okay. So you're going to write the question in your own words. Before I go any further, one more thing I have to tell you why I ask you to do that. It might seem like I'm saying a lot of stuff about like teacher, student, assignment, like this is what I want and this is what you do. Yes, some of it is that. But actually also, not only is this all practice for the exams, it's also practice for research and publications and like real science. And what we're really trying to do, especially for those of you who are getting bored or you already get it, or you're like, yeah. What's really happening here is I'm trying to teach you with the 5-step method. I'm trying to teach you a way that you can turn my assignment into a proper, standalone, independent physics document. Like, if you follow this method and you take each of the questions and you write them in your own way after you make a diagram and then you start proceeding, if you'll know you've really done this right. At the end of the day, you'll know that you've done this method right for two reasons. One, because it's going to start showing you how to get answers that you don't think that you can get otherwise. Like, you'll know the method is working because you're going to start getting answers to things that when you first look at them, you're like, what? I don't even know what this means. Like, in fact, often you might remember from high school physics, a lot of times, a lot of us look at physics questions like in high school physics. A lot of us look at physics questions and are like on exams, and we're like, wait, are you serious? Like, I literally don't even understand what you're asking me. Like, I even studied. I did my homework. I'm a good person. I'm a Girl Scout. Like, whatever. I'm a Boy Scout. Like, I don't even know what you're asking me. Like, what? And yeah, like that was my experience in college, in graduate school. That happens in physics. So a big part of the exercise is like actually stepping back and going like, what does this question mean? And when you rewrite it and you put it on the paper and then you start solving it according to this method, the other thing you're going to find, besides the fact that you'll get answers when you at first didn't even think that you knew what the question was, but the other thing you're going to find is that when you're done, you'll have a bunch of pieces of paper that you could hand to any physicist or any physics professor or whatever and say, what do you think of my work? And they don't have to have my original assignment to know. They don't have, you're making work that would stand alone and that ultimately could be a proof of NumberLine, kinematics, or whatever that you could put in a magazine and people could read, and they don't have to view it as a reply to an academic, like in-class assignment. You're trying to turn my assignment into actual standalone physics. So you'll know you've done this right if at the end you could step back and look at it or hand it to someone and they could follow it or mark it without any other pieces of paper as reference. That's the goal. Okay, so hopefully that makes sense. All right, so I'm going to go on. So you write down the question. Again, it'll be more and more clear as the problems get more sophisticated. But all right, so you write down the question. That's step 2. Then step 3. And again, if any of you are saying, well, this is great that he's explaining this now, but I didn't know this or I didn't get this when I was doing the homework last night. I understand. That's why you can revise and get all the points tomorrow. Like, I know. Okay. But now you know. So step 3, GDP means general definitions and principles. So now you're going to write down, in this case, so, and you don't, in fact, one thing is, everything I'm doing right here, you could imitate as your homework, except, oh wait, I'm sorry, I'm looking at, oh, good. Oh, great. I'm looking at the direct, oh, sorry. Oh, hold on, there's direct chat. One second. Sorry, it's recording. Okay. Trying to respond to, well, okay. All right. I want to go. Oh, but one other thing to be clear, one little thing I'm not literally, if you're trying to figure out how to do homework, in this class, for this, you can like copy what I'm doing. This is the model. The one thing is you don't write down in your homework in big letters like step 2, step 3. You don't have to do that. You could put them off in the margin. You can label your steps, and that's a good habit even for exams. If you want to label your steps, this is step 1, step 2. That certainly helps me, but you don't have to make a big production like that in Brown, like where I am now. So maybe I'm just trying to show you them now. Anyway, so step 3, GDP, this is where you would write something down such as, well, okay. I'm just looking at the time. Okay. So here, notice a couple of things. I'll try. Okay. I'm trying. Basically, when I write in Brown, I'm trying to follow a model here where if I write in Brown, I'm writing like as the teacher to you. You wouldn't necessarily include this in your homework. And anything I'm writing in black, like, is what you would do. Okay. So a couple of things about this now. First here, also. Okay. So this step 3, general definitions and principles. Like, to be concrete, what you would write in this example, what you would write in this example is like, okay, distance is defined to be total space traversed throughout a journey. All space accumulated independent of direction. Notice this is a definition that sort of came from the sheet, but I'm using my own words to capture it. It's not the exact same words as in the sheet. Like, you would do the same thing. Also notice that as we get more into the real stuff, this would probably tend to be an equation. Like, it won't be a whole bunch of English like this as we get more and more into physics. But what you're writing down here, this goes back to like whenever you guys were learning how to solve word problems in math class in 6th grade or something like that, I'm sure many of you are aware that like there's methods where people say first write down what you know and then write down what you're trying to solve for, and then we're like, I agree with all that, but we're being more specific now. We are being more specific than just write down what you know. Notice in step 1, you already wrote down what you know, in the sense that in step 1, you wrote down what you know about this problem. In step 1, you presented the facts, the particular information of the problem you're solving. And then you presented what the question is about that problem. Now in step 3, you're writing down things that you know, but that you knew even before you faced this problem. This is a very big distinction. It's like a super important distinction in physics. You're now writing down some kind of thing that we know in general in the universe. Usually it's going to be like a law or a definition. Sure, it's going to look like an equation, but honestly, as we get more and more into physics, everything's going to look like an equation. Even step 1 will have a lot of things that look like equations. So I'm here to start, before we go any further, I want to make clear that there's actually 2 different types of equations in physics. You might not know this from high school. Or there's really 2 different types of equal signs that are really important to keep straight in physics. And again, this may be new information to some of you. So even those of you who feel like you know what's going on, there's 2 different types of equal signs. There's double equal signs and there's triple equal signs, and they're not the same thing. So that's why I wrote it in brown. Now I'm talking to you as a teacher, and I'm not saying you would write all this in your homework, but I think you want to know this for your homework. Triple equal signs are what we use when we're saying that 2 things are equal by definition, or one thing is defined to be the other. Definitions are always true. If they're true at all, they're always true. So if you've already gotten to the point where you saw on the sheet or you saw on the next sheet, like average speed equals distance over time, right? I'm getting like slightly ahead of myself, but like average speed equals distance over time. And as many of you know from high school or whatever, from other classes, we're eventually going to write that as an equation. Like soon we're going to write that as an equation, like V equals X over T or something like that, or V bar equals X minus X naught over T. I want to caution you right now that that equation takes a triple equal sign. That type of equation, average speed equals distance over time, that is not something that anybody ever discovered in a lab. Therefore, it's not something that anybody can discover to be wrong in a lab. That equation is never going to be wrong if it's ever right, because that equation is just saying from here on in physics, when we use the term average speed, what we mean is a shorthand for distance divided by time. It's not a discovery, it's a definition. So it's super powerful. It's always right. As opposed to when we say something like at the end of our answer of all this, if at the end we say distance here in this problem, distance equals 21 feet or something, well, that's a discovery. Like that's about this problem. It's not true in other problems. And also, like, maybe we got it wrong. Like maybe we, so double equal signs are about reality, are about discoveries that actually are not necessarily perfect. Triple equal signs are perfect, but they don't tell us anything about reality, okay? So in step 3, what you're generally looking for when we start writing these things in equation forms, what you're going to write down in step 3 is probably something that has a triple equal sign in it. Okay, that's hint number one. And again, in step 3, you're writing down the things that you know even before the problem starts. So I'm going to move on. I know I'm taking a super long time even to just do the first question, just because I'm trying to show you how to do it. Of course, we're going to go faster and faster. Please don't like leave the building just because it's just like so boring. I mean, or whatever. But this is like the model. So step 3, step 3 is honestly when we start getting into problems where when you look at them, you're like, whoa, this is hard. Like, I get what he's saying, but I don't get what to do. My advice is that 9 times out of 10, where the real thought has to go into is step 3, is like, what is the general principle that you need in order to start turning the crank on this problem? But anyway, all right. So step 3, in this case, it's not a big deal. Like, so you write down distance equals this. So then, and again, stop me if I'm not making sense. I'm looking in the chat. I'm looking, it seems like it's okay. Okay. Step 4. So then comes step 4, which is PAW, particular application and work. So now, I know you wouldn't have gotten this far in science and math if you've been doing science and math problems and handing them in for like years of your life. So you've heard for years, like show all work, like you all know how to show all work. My point is that generally speaking, when people think they're showing all work, they're showing all the stuff that goes here in step 4. And generally speaking, everybody's annoyed by showing all work when they're in high school and college. I always hated showing all my work because I always started showing all my work here in this step. And if I knew how to show all the work, then I meant the problem wasn't that hard for me. And I could do it in my head basically. And I was just like, as an exercise, writing out the things that the professor or the teacher wanted to see, and they weren't really helping me. And if I didn't know what worked, like if I couldn't solve the problem, then I didn't know what work to show. And so there was nothing to show. So it never did anything for me. But really what I'm saying is to show all work means first to set up steps 1, steps 2, and step 3. They will get you going. They will bring you into the problem and start showing you what to do, even when you think you don't know what to do. And then by the time you get to step 4, now you're ready to go. Again, I'm talking about with harder problems. I know with this problem, probably you didn't have to do all this. Step 4 is when you take the general truth, definition, whatever, and you apply it to the particular situation. So now you're really like zooming down from a triple equal sign to a double equal sign. So now is where you now is where you're going to substitute in. You're going to track units. And perform like algebra, calculus, whatever, computational tools we're using, perform algebra or trig, calculus, whatever. So now you like do the math. But again, my point is don't start with this. People make the mistake of starting with this, which is useless. If they know where to start, then they don't need this. And if they don't know what to do here, then starting here is too late. So now we would say something like, and the way you would know you're doing a step 4, I almost always transition to step 4 by using the word here. Like I would say something like, here, the distance equals, notice now I'm shifting to a double equal sign. Here, the distance equaled, so I'll put it like this. Like, first he went, sorry, I'm just looking at the bit. First, I'll put it this way. Like -4 minus, sorry, not -4, -2. -4 minus 4 plus the absolute value of 4 minus -2 plus the absolute value of -5 minus 4 equals, I believe, 6 plus 6 plus 9. Right now, I'm going to pause for a second. Like, where did I just get that? I mean, I don't think most of you like necessarily wrote out everything like that, but what am I doing here? I'm saying that if distance equals each chunk of all the space that's accumulated, every time we cross through space, we're putting that into a pile of space that we're calling distance. So, and we don't care whether we go to the left or to the right. So, sorry, we don't care whether we're going to the left or to the right. So since I don't care, I'm using absolute value symbols right now. I'm just introducing this right now to you as my way of thinking about this. I think distance equals the sum of absolute values of intervals. And the interval that when you get from one place to another is like the final place minus the initial place. Where did I get that? Is that a formula or an equation? No, well, it sort of is ultimately a definition in the sheet, but I also think it's logic. I think like subtraction is what we do when we're looking for a difference, right? I mean, if you remember from like third grade or whatever, they call adding two numbers together a sum, and they call subtracting two numbers a difference. So if you want to know the difference in where somebody got from when they were here to when they were there, you want to subtract where they are, and you want to subtract where they were from where they are. I'm speaking fast because I think you all actually get this, but I'm just trying to encourage you to see, I'm not making this up. It's all in your minds already. But I think if I'm going to do the total distance, I'm going to add up a bunch of absolute values. So the absolute value of -6 plus the absolute value of 6 plus the absolute value of 9. That's what I think I'm doing in this step. That's the math. Again, of course, most of you did this in your head. I know that. We'll address that again in a minute. But what I'm asking you to do is acknowledge that you did do something in your head and it looked something like this. So this is what we're writing down. So that's step 4. Wait, I'm just looking back. I'm switching screens, looking in the Zoom. Okay, nothing in the chat still. Okay. And obviously we'll take a pause when I get through this first one. So now I go to step 5. FAC, final answer circled. Oh, sorry. So here, I mean, it was almost staring me in the face in that last step 4. So here I would say, like thus, I would say total, oh, sorry, for 21 seconds, total distance equals 21 feet. Where did I get 21? I got, 6 plus 6 plus 9 is 21. So this is my final answer. Now I'm going to pause on this for a second. That's like literally my final answer. Notice a couple of things. My final answer is a complete thought. My final answer is a complete thought that completely addresses the original question, right? The original question was, for these 21 seconds, or 4 from t equals, oh, is that what confused Melanie? Wait a minute. Did I write from t? Oh, sorry. Sorry. For 8 seconds. I'm sorry. Thus, for 8 seconds, see, thank God. Notice I would not have caught that error if I hadn't remembered Melanie's question. So Melanie's question was firing on more cylinders than even she might have thought. So questions are good. So thus for 8 seconds, the total distance covered equals double equal sign equals turns out to equal. I discovered that it equaled 21 feet. That's my final answer. It's a complete thought. It's a statement. If I just handed all this work with the diagram and everything to somebody who never saw this class, never saw the homework sheet, but if I just handed all these pages to someone, they could read all through it. And it makes sense, right? Like they're like, oh, if I'm in this situation, okay, this dude is going back and forth, blah, 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 blah. Oh, and the question is, how far did he go distance-wise in the 8 seconds? Okay, oh, here's the work. Oh, and here's the answer. Like this, it wouldn't be the most interesting journal article, but it could be a journal article, right? Because, I mean, it would really be a journal article if we took it one step more, like we're going to, and turned all these numbers into letters. And then it's like a proof of how you analyze distance in general. I'm not saying you would get a Nobel Prize, but I'm saying anybody that could follow physics could follow this and they don't have to be in the class. That's what we're going for. So this is my final answer circled. It's a complete thought. It has units in it like science should, and it addresses the original question. Last thing, when I say it's a complete thought, I mean, it has an equation in it. I mean, that's an equation. It's in English, but it's an equation. An equal sign, a complete thought means something with a subject and a predicate. I mean, a noun and a verb. In math and physics, the verb is always equals. So this is a complete thought, but notice also it specifically captures the condition of the problem. It doesn't just say total distance is 21 feet. Like, what does that mean? Total distance what? Of the universe? No, it's like it says for 8 seconds. Maybe I should even say of this guy's journey or whatever. Maybe that's even better. Of instructor's journey. The total distance equals 21 feet. Okay, now I'm looking at the time. This ends at 12:05. Okay, I'm going to pause in a second. I'm just going to say, that's an example of how you would do the first question. I'm going to start moving faster for the rest, but so for the remaining ones, you don't have to redraw the diagram every time. If all of the questions are referring to one diagram, which is very common in physics, of course, you don't have to keep doing the diagram. You could say see diagram above. That's fine, but do say it. So every question from now on, you want to address these 5 steps of the method. It will seem very kindergarten-y to you at first. I recognize that. Right now, when you can do them in your head, it's annoying to have to write all this out. I appreciate that. I do. And that's why you're getting points for doing it. The thing is, the whole purpose of the method is that you, by writing down what's in your head, in this way, when you're writing down these thoughts, if you can practice this now with questions that many of you, and not all of you, but many of these questions were somewhat straightforward for many of you. I think the last couple ones are sort of harder, so I'm going to talk more about them. But I understand that a lot of these you can do in your head. What I'm telling you, though, is even if you can do these things in your head, give yourself credit. Don't think that because they come into your head, that means they're obvious. They're not obvious. You're just smart. And if you're seeing the answers right away in your head, it's not because they're coming to you in a dream. It's not because the question is magically, spontaneously putting an answer in your mind. It's that your mind is very rapidly going through many steps of thought because you're very smart and very well trained. That's great. But what you want to do is take a movie of the steps that are going through your mind and place that movie on the piece of paper here. Because, like, honestly, partly for me and partly so you get all the points. But the whole idea is when we start getting into physics questions, and again, some of you might have had this experience in high school, we're going to get into physics questions where it's not as simple. And where you look at them, you're like, I don't even, like, people classically say, either they say, I don't even know what you're asking, or if they sort of do know what I'm at, they go, I have no idea where to begin. People say that all the time. I used to say it all the time. I have no idea where to begin. I'm here to tell you, you do have an idea of where to begin. Like you do. What to do when you don't know what to do is follow these types of steps. So the more you can practice them when you do think you know what to do, the more you've built a life raft that you can get in when you don't know what to do. But you won't be able to get in that life raft if you haven't built it on dry land. I just totally mixed the metaphor, but you understand what I'm saying? Okay, so bottom line, you get all the points on these homeworks and on exams. If you do every single one of these steps, like honestly, even if the last answer, the final answer ends up being wrong, it's still possible to get a full credit, even on exams. You're getting the point, so it's not wasted effort. You're getting the points for doing these steps. Even if you didn't know last night to do this, you'll return it in and now you know to do this. Conversely, if ever, when I start marking more quickly in the future, if ever I just like write on the margin GDP or step 3, you now know what it means. It's a grading rubric from here on in. If you're not getting a perfect score on an exam or on this, it's because you're missing one of these steps. And I'll just quickly tell you what the step is. I might not even always say -2 or -3. You have to, you just now know if you want to get those points back, you've got to do that step. So it's a grading rubric from now on. I'm going to So of course we have 14 minutes. We have 14 minutes. I want to give you some more answers from the sheet so you can at least know if you're doing it right or wrong. Like a lot of you did a lot of work, and I totally applaud that. So in a minute, I'm going to proceed more. I'm just going to actually write down answers so that you have some satisfaction. So from here on in, it's on. So this is a model of what to do. From now, I'm not going to do that right now. I'm just going to give you answers. And then you'll ask me questions of where you fall apart or whatever. But let me pause for a second. Can I just, I'm just changing the view so I can, obviously all this will be uploaded, also all that stuff. Okay, so can I just get like, can I just get thumbs up if we're clear so far, if this makes sense, if we're good to go on and thank you, Melanie, thank you,
I
Gabriel.
have a
Oh,
question.
yes, Annie. Okay, but thank you guys. Thank you, Jean. Thank you, Vanita. Yes, Annie. And Gabriel.
So on our like homework, do you want us to write out like step 1, step 2, and or is it just implied if we show like all of the procedure for the 5-step method?
Right, that's a perfect question, and I know it's confusing that I'm doing. So you don't have to. It's a great question. If you do it really clear and nice, you don't have to write like step 1, step 2. But I will admit, especially for practicing for exams, if off in the margin, like if after you do all the homework, if off in the margin, you could just like small, just like with arrows, just go like step 1, step 2. That only makes my life, that's more helpful for you and me. It's almost like you're doing a pre-checklist, or you're almost like helping me grade. So it's helpful. It's super helpful if you can just like off like label step 1, step 2. But I won't take off if all the steps are there. I won't take off points if the labels are not there. But it actually is really good advice. It's a good thing for you. Just off in the margin to just make quiet little labels like that, and it just helps our communication. But so right, does that make sense? Is that okay?
Yes, thank you.
Thank you. Okay, so that was closing the loops. Okay, great question.
Can you reiterate about what you said? So like for example, let's say question 2 is the same diagram from question 1. Do I have to redraw it?
Great question again. Great question. And no, you don't. Because often this will come up in physics. Often the problems will be like this: one big diagram and facts at the top, and then lots of little questions. So each next question you can just say, see diagram above. But please do say that. Like, so you want to address every one of my steps, but right, you don't have to and you do not have to keep redrawing the diagram, but just like give me an arrow or something, see above. Does that make sense? Is that
Yes, it makes sense.
great? And all these questions are great, especially at this stage of the year. Like again, of course, there comes a point in this class and in physics where if I've said something like 6 times, maybe I don't want to say it a 7th time, but I'll let you know where that point comes. We're still at the stage. This is where I want everybody to know what's expected, and we want to maximize our chances of doing everything right. So if you're thinking so basically I'm saying, don't be shy about asking me to say something like what Annie and Melanie just asked. Even if you think it's possible, I might have already said it, it's okay. So no, those are great questions. So, and again, we're at the stage again, even if you don't we're trying, again, the homeworks are practice for the exams. It's all the same grading expectations, the same format expectations. And the exams are practice for actual research or publication or whatever. It's all met. So we'll keep doing it the same way for 2 semesters. So you have a little time to get used to it, believe me. And I will talk faster and we'll move faster and faster as we go. So now, we have 12 of it. Any other, okay. I see something in direct chat. Bear with me for a minute. Yeah, okay. So here's an example now. There's a question in the direct chat. I'm telling you right now, it's a great question. I feel like a lot of people, I'm going to read part of the question out loud. I'm not going to read the person's name or anything like that, but it is a great question. I'm going to paraphrase it. Right, for the first step where I do diagrams and labels, do we label each specific part? For example, in this diagram, I had the different times. Would you label each of those like T1, T2, T3, and label each distance 1, 2, 3? So yes, the fast answer is yes. Different specific parts, should be labeled different ways. The more you, when in doubt, yes, the more you focus on labels. If you ever have a question in your mind, should I over label or under label? Over label. Yes. Again, here, this problem is a little weird because it's designed to be a problem where the problem wouldn't stress you out too much. So therefore we can focus on all these steps. But the truth is, it's such a weird problem that it's not as clear to see how to label diagrams. You're going to see in future like in homework 2, it'll be, once we have like letters and equations, it'll be even clearer to see. And you can remind me of this question again then. But yes, when in doubt, over label. Also, similarly, oh wait, and you could tell me in the private chat if that answered or not. And all of anything in private chat counts for points too, for sure. Oh, great. Okay, awesome, awesome. When in doubt, also over include. Like anytime you're trying to do homework or exam and you're thinking, wait, something just went through my mind, but like I just divided both sides by 2. Does he really count that as a step? Like, am I really supposed to write down, divide both sides by 2? The answer is, if it even went through your mind, if it's even occurring to you to wonder, then yes, it's a step. Like the more steps and the smaller steps, the better. And that's okay. So, okay, we have like 8 minutes. What I'm going to do right now then, so we can keep moving forward in the course, right now I'm just going to write down the answers to just the answers, so you can like know. And again, if they can help you revise and good. It's not cheating to use this information to fix your homework to get all 20 points. I'll let you know once like that's not okay. So bear with me for a second. So I'm going to change the screen again. Hold on. Well, yeah, okay. And then at 12:05, when it's time to go, then go, but I will stay. Oh, and actually warn you too, there's always a class right after this. So if you want to stay for a minute to ask me something, it might turn into that we're making an appointment. Like I won't be able to get into anything involved, but again, I will be here until everybody leaves in case you have any kind of issue. Okay, so I'm going to write down the answers as quick as I can. In fact, I'm literally just going to write because I know we're running out of time. So, well, okay.
Is it possible we could also leave our answers in, can it either be in fraction or decimal form, or it doesn't matter, right?
Great question. Great question. And you're correct. It doesn't matter. Either way is totally fine. Great question. Great question. And also, and I can't see right now because I'm looking at the thing, but yes, great question. Either way is fine. Also, I'm just giving the answers now so you guys have perspective. Next class when we meet, you definitely can and should go back and say, wait, I don't know how you did number 3 or whatever. Like this is not the last we're talking of this sheet. I'm just doing this so you have some satisfaction or help or whatever. But yes, either way is fine. And also, what was the other thing I was going to say? Also, oh, also, units are units. Like you should present your answers in the units that the original question. Like, don't convert these to centimeters just because you think science likes metric more. I mean, we could talk about it, and maybe science does, but if these things were presented in feet, leave them in feet, and vice versa. Okay, but yeah, that's right. What I assume that was Melanie. Okay, so average velocity. And you'll note, you see how it's not, I'll explain this more next week too, but notice with things like speed and distance, I'm leaving them in English. But then once it's like displacement and velocity, I'm starting to turn them into symbols. You don't have to have done that yet. I'm going to define all those symbols next week, but it's just a habit I'm starting to get us into. I don't even remember now. Oh my God, I don't remember. Oh yeah. Oh yeah. And well, yeah. Wait, it's 12:01. Okay. If you can't read, sorry, you probably can't read this. Okay. Okay, now I'm going to turn we're 3 more minutes. I want to turn the page. If we have time, I can turn the page back, but remember, all this is going to be uploaded as a PDF in a minute anyway, so just bear with me. Okay, I'm going to leave it at this for the moment. I'm also going to turn back the page in a second if you want me to, or someone asks me to right after, or maybe you already asked me to try. I'm sorry. I'm not going to do the part 3 is the hard part for sure. It takes it. So those of you who have already submitted or are resubmitting, or maybe I indicated that maybe you didn't get the last 2 correct, because the last 2 are the hardest. My advice is to focus the hardest on step 3, like GDP. And a bigger hint is what if you believe that average speed equals distance divided by time, then flip that in your mind and realize that then therefore distance has to equal average speed times time. But it's only true for each, like you have to do it one interval at a time. Like the average speeds are different for each of the intervals. That's just like my quick hint for that. But okay, I'm going back to the screen. So it's 12:04. Let me look at the chat. If is there anything in the chat? Okay, it's 12. If you're good, I think that's a fine stopping point. I don't want to go. So if you're good, I'm good. You can leave. Like have a nice day, and I'll see you on Monday. But if you have but text me anytime or email me anytime, or you can find me in my office next Tuesday or blah blah, or hang out for a second if you have any other issues. But what's due to Monday is try to revise this, but try the next one. It's a little bit harder, but it's the same idea, and we'll have time to catch up. Blah 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 blah. So bye. Yes, bye. Thank you, Melanie, for saying bye. Bye. Yes.
Have a nice
And
day,
I-
Bye,
Professor.
thank you.
Thank you. Have a nice day. Okay. I'm still here. I'm just turning off the recording. Okay.
Professor, I have a question.